Shall we start or?
Yes, please start.
So, very good evening to one and all. I, Dr. Kiran Bala, on behalf of Deshbandhu College, welcome to our chairperson, Professor Sadha Pasricha ma'am, and participants from the various areas across the globally. I now take the privilege to introduce our chairperson of this oral session, Professor Sadha Pasricha. Professor Sadha ma'am is currently working as a professor in the Department of Chemistry, Sri Venkateswara College, University of Delhi. She is synthetic organic chemist by training. Her current research interest includes catalysis, homogeneous and heterogeneous nanobiotechnology and its application to organics, transformations, green chemistry, heterocycles, and their biological applications. She has published many research articles in national and international journals and several e-modules for undergraduate students. She is in the review board of several prestigious journals. She has been awarded with several fellowships and teacher award in her career so far. Welcome, ma'am. Now I would request our chairperson, ma'am, to take the lead and start the session.
Thank you so much, Kiran, for the kind introduction. I will request the first participant, Baban Mohan Malik, to start his presentation, please. Mr. Malik, are you there?
I think he's not here, ma'am. I
Can
will take the
Can I go to
attendance.
the next one? Can I go to the next one?
Yeah, next one is Madhav Singh.
Madhav Singh, are you there? Madhav Singh? I don't see him here.
Not here. And I think third participant is Perkob
Musa. Yeah, Perkob Musa, are you there?
Yes, ma'am, I'm there.
Okay. You can start your presentation, please.
Okay, ma'am.
Ma'am, shall we tell them rule for the presentation? I think we are giving 8 plus 2 minutes, total 10 minutes, 8 for the presentation and 2 for the questions answer session.
Disabled. Okay.
Parkob, have you understood the rules? You have 8 minutes
Yes,
for
ma'am.
and 2 minutes for interjection.
Okay. Ma'am, is my screen visible?
No, not yet. Please share your screen.
Actually, I'm sharing my screen, but it's showing that host disabled participant screen sharing.
किरण एक बार चेक कर सकते हैं?
Rona?
Yes, ma'am.
Please help her know how to she can present the presentation.
It's showing that host has disabled, ma'am.
Host is disabled. Okay.
Yes, host has disabled screen sharing.
Yeah, actually, her screen sharing has to be enabled.
Ma'am, let me go on. Yes. They will allow. Okay, just wait for minutes.
Okay.
Is anybody keeping track of time?
Ronak, are you keeping?
Yes, ma'am.
Okay, beta.
Good.
So when the 8 minutes finish, you must ring a bell so that the person knows that they have to stop. Or we can do one thing, beta. We can ring the bell at 7 minutes. So that will indicate that 1 minute is left, so that they will be alerted.
Okay.
Can we do that?
Yes, ma'am, definitely.
Okay. So we will be ringing the bell, all the presenters, please note. We will be ringing the bell after 7 minutes. So you will have 1 minute after that. And Ronak, you again ring the bell after the 8 minutes is over. Okay?
Okay, ma'am.
Yes, now it's visible.
Ma'am, is it visible now?
Yes,
Yes,
it's
yes.
visible now. And put it on the screen. Screen.
screen.
Yeah.
Please change it to full screen mode.
Shall I start, ma'am?
Yes, yes, please start. Your time starts now.
Okay. Okay.
Ronak, ready?
Okay, ma'am.
Yes, ma'am.
Good evening, everyone. My name is Ferko Mosang. I'm from Department of Botany, Rajiv Gandhi University, Arunachal Pradesh. My topic is metabolic profiling and in silico evaluation of therapeutic potential of the metabolites of Taxiphyllum mania, M-flash. So this is a short introduction about the plant. Taxiphyllum mania is a moss belonging to the family Hypnaceae. Plant is yellow-green and somewhat glossy and dioecious plant. Here is the pictures of the plant. It is not very visible. The characters are not very visible, but costa is short double and leaves are widely spreading, narrow, ovate, lanceolate, short, acuminate, margin dented, flat, and sporophytes are not seen. So these are the taxonomic characteristics by which we have identified the plant. And we have, this is the materials and methods the picture shows. I have collected the plants and then I have washed it and dried it, and then I have grinded it and made and concentrated it in methanolic solution, and then I have done the GCMS of the extract methanolic extract of Taxiphyllum mania.
Sorry for
results-
interruption, but I think your screens are not moving. Your slides are not moving.
The screen
Still
is
it's on
frozen.
the. Yeah.
Is it moving now, ma'am?
No, not yet.
We are still on slide 1.
Okay.
The title slide.
Oh, okay. Let me just check. Yeah. Stop share. Is it visible now, ma'am?
Yes, just move it.
Yes.
Go to the next slide. So
Please check
Okay.
one more time.
yeah,
I will go on to the navigate. Yes.
yeah,
Now
it's
fine.
working.
Okay, so I have already described about its taxonomic characteristics, and this is the plan which I have taken for the GCMS and for molecular docking as well. So this is the material and methods. I have collected plan the plant species. I've collected the plant species, then I have washed it, and then I have dried it, and then I made grind paste of it, and then I have concentrated it in methanolic solution, and then I have done the GCMS of the plant extract. So this is the result. The result showed the gas chromatography and mass spectrometry of methanolic extract of Dexyphylum mania has shown 43 compounds. Of these 43 compounds, 5 compounds were found in the highest number, highest concentration, I mean. So these are the 5 compounds which were highest, which was found in highest concentration in the Dexyphylum mania species. This is the graph. Further, I have done the molecular docking, and using sweet acne, I have physicochemical properties of these top 5 compounds were determined. Those it included molecular formula, atoms, heavy atoms, rotatable bonds, hydrogen bond acceptors, etc. All these physicochemicals were analyzed. And the slide is continuing. And the table 2 shows the highest probable 15 highest predicted targets of the compounds. These are the 15 most probable predicted targets of compounds which have been determined using Swiss target prediction software. Table 2 shows the molecular docking of these top 5 compounds. These are the molecules, and these are, out of these 15, I have selected the top 1 target protein, target gene, and I have done the molecular docking of the molecules with the target protein, target genes, and shown their affinity. The more negative it is, it shows the more strong binding with the molecule. So 1 second, ma'am. So these are the 1 second, ma'am. These are the 15 target genes belongs to the different classes. Some may belong to the class of enzymes, some may belong to the class of nuclear receptor, and some might be membrane receptor. So this is shown in the slide. And in the compound number 1, it is two color. It belongs to the highest family of enzyme, and in second, the 33.3% shows the nuclear receptor, and in compound number 3, phytol, the highest 46.7 shows the nuclear receptor, and in compound number 4, the highest 40.0% shows the oxidoreductase, and in compound 5, the highest 33.3% shows the cytochrome P450. And figure 2 shows the KEG pathway associated to the top 15 targeted genes. So these are those 15 targeted genes belongs, like they regulate various kinds of pathways. So these are those pathways which is shown in this slide. Slide is continuing. These are the 4 compounds, and the 4 compounds KEGG pathway is shown in the slide, and for the 5th compound it is shown here. Figure 3 shows the disease associated to the top 15 compounds, and these are the disease associated with the 15 predicted target. These are the 4 compounds of the plant, and their disease association is shown in this slide. And the next slide shows the fifth compound and its disease and the disease associated to it. The last slide shows interaction between compounds and target proteins. This slide shows the interaction of the compound with its target proteins, and the slide continuing to the 5th one. And therefore, it shows that the T. texophyllomania could serve as a source of biocompounds which have the potential to cure various diseases.
Sorry to interrupt you, ma'am, but
Thank you.
Any questions from participants? If there are no questions, let us all thank Feruko for a very exciting presentation. I think Baban Mohan Malik has joined. Baban, you can start your presentation now. You have 8 minutes time. After 7 minutes, there will be a bell to indicate that you have 1 minute left. And there will be another bell after the 8 minutes have finished. And you will have 2 minutes for interjection. Okay, please start.
Thank you, ma'am.
my slides visible.
Yes, it's visible.
Okay. Good afternoon, everyone. Myself, Baban Mohan Malik. I am doing my PhD from
Can you
Sharda
be a little
University.
louder, please? You are not audible. Can you be a little louder?
Myself, I am Baban Mohan Malik. I am doing my PhD from Sharda University, Greater Noida. Title of my research paper is Design, Synthesis, ADME, Docking Study and Biological Evaluation of Methyl piperidine for phenyl nicotinamides analogs. I am doing my study on disease cancer. Everyone knows cancer disease the most after heart disease, the second most death in the world, in the entire world. In the cancer, cancer is the uncontrolled growth of the abnormal cells in the body. There are types of cancers, but number of types of cancers. But I'm working on. I'm doing my study on leukemia in blood cancers. These are the information available. I will go directly to my findings. The diagnosis is ultrasound. These are also known informations. Signs, symptoms of cancer is including. These are also known types of cancer treatment. In types of cancer treatments, I'm so many treatments: surgery, chemotherapy, targeted therapy, radiation. But I'm focusing on targeted therapy. In targeted therapy, there is without disturbing normal cells, kill the cancer cells. In that there is tyrosine kinase inhibitor is used. These are the tyrosine kinase inhibitor currently used in the market for blood cancer treatment. asciminib, bosutinib, ponatinib, imatinib, dasatinib, and nilotinib. And so I mostly now I'm focusing on the target asciminib drugs, and I designed the molecules on asciminib best. These are my designs. Those were good at showing the good biological activity. That out of 15, I selected the 6 ones for this conference. And I have done all the design energies of these good binding energy scores of my compounds. Out of 15 is and these are the ADME data of my design compounds. Out of this 9C showing the similar to drugs asciminib. If you seen that hydrogen number of hydrogen acceptor similar to the drugs asciminib 7, number of hydrogen bond in asciminib 3, in my molecule is 2, and log P is around similar range. As per Lipinski rule for the drug discoveries, number of hydrogen bond acceptor should be less than 10. So in my molecules also in the range. And number of hydrogen bond donors less than 5. This is also similar. In my molecules is almost 2, and this is log P value of these my compounds in between less than 5. Yeah. And always 2 to 3 is the less than 5 is the good value for log P for drugs in drug discovery. And log S also solubility also in the range as compared to drugs asciminib. For my study, I have done docking studies on Schrodinger software and molecule. Those who are good docking scores, we are selected for synthesize, and those who are all the compounds synthesized in the laboratory, characterized by proton NMR, carbon 13 NMR, LCMS, and HPLC. As well as I have done the biological activity evaluations for my compound using K562 and MB411 cell line. These are blood-related cell lines. Now, how I synthesize my molecules. This is my general schemes for synthesis of my all targets. In 7 steps, 7 to 8 steps, I prepared my all desired targets. Starting from 2 chloro, 5 methyl pyridine. In first step, I have converted chloro to amine using methanolic ammonia at 150 degrees Celsius. I got around 74% yield, and this amine I got in around 74% and confirmed by proton NMR. Also TLC, we generally use inhydrin for amine characterizations, and also my NMR also consistent with my desired product. After that, in step 2, I converted this bromination reactions using N-bromosuccinamides using solvent acetonitrile. I got around 69% yield. And this number 3 characterized by proton NMR, also LCMS. In LCMS shows this equal intensity bromo pattern. This is also confirmed by the NMR and LCMS. In step 3, converted this amine to chloro using sodium nitrate concentrated HCl. I got 65% yield, and this is a very good known Sandmeyer reactions. This is also I got yield 65%. Then in step for synthesis of 5, that methyl converted to acid using oxidation reaction using K2CR2O7. I got this acid around 60% with and the compound 5 is confirmed by NMR LCMS. Also in TLC bromocresol 5 compound is shown on TLC as well. Okay. And in next step there is a acid and amine coupling reactions, but generally acid amine coupling reaction in one steps. R2 dipia T3P, so many one in one step reactions are there. T3P nowadays COMU also available nowadays for peptide coupling reactions, but in my molecules the reactions are very low yielding, 1, 2, 3, 5% yield only, that acid and amine. But that's why I go via acid chloride route. I converted this acid to acid chloride. Final that I convert with it. I mean coupling with via acid chloride route. I got this 7, which is confirmed by NMR LCMS. Finally, I've used this S-pyridine for coupling reaction in presence of IPA. And this 8 converted to all my desired compounds in final Suzuki coupling using dimethoxyethane solvent, ethanol water, and as I use the palladium catalyst. And all compounds I got around 46 to 78% yields. Here is I mentioned in the slides the optimizations of Suzuki coupling. Everyone knows Suzuki in 2010 got the Nobel Prize and more widely used in every pharmaceutical industries. And
you have exceeded your time.
Okay, I will. And this is Suzuki coupling reactions optimized for, in my case, I need the use dimethoxyethane, ethanol water, solvent at 120 degrees, 120 degrees Celsius is the good condition. Generally, in Suzuki use tetrakis 100 degrees Celsius dioxin water, but in my case, in my molecules, yield is very low. Finally, I summarize this my presentations. I successfully synthesized all new pre-phenyl nicotine analogs characterized by all the analytical data, and all the compounds were screened in vitro against 2 leukemia cell lines, K562 and ME411. Out of these all 15 compounds, I have got 4 to 5 compounds shows active in K562 as well as ME411. Around 2 to 5 micromolars I got activity. These are references. Final, thank you.
Thank you, Mr. Baban, for your presentation. Next, we have Madhav Singh is there. Has Madhav Singh joined? Mr. Madhav? Okay, in case he is not there, Sarabjit Kaur, Miss Sarabjit Kaur, are you there?
Yes, ma'am, I'm there.
Okay, so you can please start your presentation. You have 8 minutes presentation. After 7 minutes, there will be a reminder. You will have 1 minute left. And after 8 minutes, there will be another bell for time up, and you have 2 minutes for interjection. Okay, please start.
Okay, ma'am. Okay, is this my screen is visible, ma'am?
Yes. Please continue.
Okay. Good afternoon, everyone. I am Sarabjit Kaur, and the topic of my research work is mutual induced fit controlled signal amplification hydrogen bonded capsule. And my slides are not moving, ma'am. Okay, now it's done. Okay, first of all,
what is
Yeah, now it is fine.
Yes, ma'am. Now it's fine.
Slides show.
Yeah. Now, what induced fit? This is the mechanism where rigid substrate cause flexible enzyme to change its shape to fit the substrate better. And what is mutual induced fit? So mutual induced fit when biomolecule interact both their recognition sites are flexible or disorganized initially. They mutually induced each other's organization to establish a strong and specific manner. Right? In the above picture that you see is the cartoon representation of induced fit and mutual induced fit. And as we know, mutual induced fit is very common in biological or natural systems, but in artificial system it is very rare. So here is the example of mutual induced fit in an artificial system published in JACS in 2014. In this study, they created a unique host-in-host complex, and this complex involved two flexible and dynamic host molecules that interestingly become firmly fixed in terms of their shape and composition. This is the schematic representation of our work. And this is the representation of mutual induced fit controlled hydrogen bonded capsule formation in an efficient manner. Here we use two type of flexible ligand. Here, which is shown in blue color, is a triazine bridge ligand, and which is shown in red color is a nitrogen bridged ligand. When triazine ligand is treated with in the left side, you can see benzylamine and nitroaniline. You can see the 50% major product is formed. But when we add an bridged ligand to the same reaction, a 100% sole product is formed, which is due to the mutual induced fit. And this is the schematic representation of formation of mutual induced with control hydrogen bonded capsule. As I already told you, we used a two type of flexible ligand. One in blue color is a triazine bridged ligand, and the three here, which is designated as three, is a which is in a red color is a N bridged ligand. In a red color, triazine bridged ligand react chemoselectively with benzylamine, as you can see, and form a adduct 2 and adduct 2. And the adduct 2 and adduct 3, as you can see in the slide, that they have a different various possible conformations. When these adduct 2 and adduct 3 interact with each other, they form a single conformer. Lots where they changes into a single conformer, which is named as here 4x. This 4x single conformer, when reacted with nitroaniline, they form another molecule, another single conformer, which is a 5x. And this adduct 5x undergo a solvent polarity dependent dynamic self-assembly to form a dimeric capsule. And a dimeric capsule, or at the in the last you can see the compound or the ligand or adduct 5 formed from the ligand 1 by the treatment with a mixture of solution benzylamine and 2 nitroaniline is unable to come in a cone shape conformation, hence unable to form a hydrogen bonded capsule. This may be due to the large rotational barrier in the compound. This is the C13H1 NMR and mass spectra of the ligand 1 and C13 mass, and this is the concentration, and this is the practical H1 NMR spectra of receptor 1 in the presence of benzylamine, showing the concentration dependent number and ratio of the conformer formation. Here we show flexible nature of the adduct 2 and nitrogen bridged tricodyl ligand 3 through their concentration-dependent H1 NMR spectra in DMSO D6. Ligand 1 was gradually added to DMSO D6 of benzylamine, and their spectra were recorded. As you can see, if you see the peaks here in the delta or ppm, around 4.8 were named as F. You see 5 peaks. And when we increase the concentration up to 100 millimolar, the peaks reduce to 3. So which shows reduced to 3, which shows the presence of formation of different 5 conformers. And this is nothing but it's again same H1 NMR spectra at 6.25 molar concentration, where you can see of 5 which is in the red box shows in the 5 different peaks for 5 different conformers. And as I told you, as told you earlier that our reaction is chemoselective. So this is the proof for chemoselective reaction. Here we have taken the FTIR spectra, a spectra of the ligand one, which is shown on the which is shown at the left, top left. Here you can see this is a ligand one, where you can see two peaks, which is shown in two arrows. One is for orthoformyl group, and other one is for paraformyl group. When and at the right, at the top right, you can see when this ligand one is treated with benzylamine, it react with the orthoformyl group, not with para, and we see a peak at we see the peak in IR for paraformaldehyde group, or in the left or in the left side at the bottom, in the spectra, the ligand one is treated with nitroaniline. The nitroaniline is treated with at the para position of the at the para position of with the formyl group, which is attached at the para position. So here you can see only one peak for orthoformyl group, and at the right, in the right and the bottom, you can see where both nitroaniline and benzylamine are when reacted, then no peak for available for no peak was shown, no peak was observed. This shows that our reaction is chemoselective, where benzylamine only reacted to the orthoformyl group, and nitroaniline only reacted to the ortho group. And this is the this is the H1 NMR. This is proof for the H1 NMR spectra. Spectra of the reaction. Here you for the same, and here you can see the peak shifted to little upfield due to the formation of these adducts. And here this is the flexible. Here, as I told you, our ligands are very flexible. So this is the concentration dependent titration spectra of ligand 1, 3A, 3B in DMSO D6 shows gradual upfield shift. As you can see here, which is shown in red dotted arrows. This suggests that all these peaks, three ligands, are not in a fixed conformers. I have already explained, and this is the H1 NMR spectra. This is the H1 NMR spectra of titration of adduct 2 to DMSO D6 solution of ligand 3A, and concentration of the cone shift conformation of adduct 2 increases. Red triangle inside the circle in the presence of the ligand 3A through mutual inducement. What we have done here, last, as you can, if you see this H1 NMR spectra, the bottom where we write ligand 3A, this is the spectra of ligand 3A. What we have done, we have start adding conformer, which at above you can see the 2I to the ligand 3A. With the different concentrations. As for example, we have the 6.25 millimolar concentration, and then 12.5, and then 25 millimolar, 50 millimolar, and then 100 millimolar. At 100 millimolar, you can see that at 6.25 we have observed a bunch of peaks, but around 100 millimolar the peaks reduced to 3. These 3 peaks here one peak is very intense, which shows the presence of cone shaped conformation type capsule is formed. And again, this is the H1 NMR spectra at 400 megahertz in DMSO D6 where where we have taken where this is the same reaction where we take a ligand 1 and benzylamine at the different concentration at 6.25 millimolar concentration. At the left side, you can see 5 peaks. 5 peaks of equal intensity, and on the right side of the top you can at 100 millimolar concentration where the peaks are reduced to 3.
You have exceeded your time.
Okay, ma'am. So I directly come to the this is a nosy and dozy NMR, which shows that our capsule is formed, and this is the polarity dependent mutual induced fit in the mutual induced fit hydrogen bonded capsule through dynamic self assembly, and this is the theoretical representation of our cone shaped conformation. This is the selected references, and these are the publications. Thank you.
If there are any questions from the participants, you may please ask the presenter. Any questions? Please raise your hand. Okay, so there are no questions. Thank you, Sarabjit, for a very nice presentation. We will move to the next participant. Is Shilpa Yadav
Thank
here?
you.
Yes, ma'am, I am there.
Okay, so have you listened to the rules that we have detailed earlier?
Yes, ma'am.
I will repeat again, no time, no worries. You would get total of 8 minutes. After 7 minutes, there will be a reminder, so you will have 1 minute left. After 8 minutes are over, you have to finish your presentation, and there will be 2 minutes for the interjection. Okay?
Okay, ma'am. Okay, thank you.
Yeah, please start. Share your screen and start your work.
My presentation is visible.
Yes. Your
Uh,
time starts now.
yes. I am Shilpa, research scholar in Guru Gobind Singh Indraprasth University, and my presentation topic is a DFT study on subsequent solvent and temperature effect and mechanism of Diels-Alder reaction of hexafluorotubetine with furane. First is introduction. Diels-Alder reaction is the one of the most common method in organic chemistry, reaction between the diene and dienophile to form the six-membered ring. This conversion proceeds through the transition state mechanism. The process studied through the transition state mechanism is by quantum mechanics. This study has been this reaction has been studied for various type of substituents, solvents, catalyst, as well as mechanism. Different parameters like NBO, IRC, activation energy, and theoretical cycloaddition reaction is very helpful to predict the reaction is feasible or not feasible, as well as spontaneous or non-spontaneous. I have studied the reaction between the hexa-2-fluorobutane and substituted furane. Furane is the most common compound in organic chemistry, and as well as in Diels-Alder reaction. Various type of publications is published with the in furane. This is because fluorinated compound had wide applications in pharmaceutical function materials, as well as insertion of fluorine in Diels-Alder reactions improves the biological activity of that compound. The present study is focused on 4+2 cycloaddition reaction. This is the given below the scheme. Hexafluorotubetane with monosubstituted furane to form the adduct 3, and the final product is 4. Computational methods and models. First, we have to optimize the geometry of different reactants and products as well as adduct. Then NBO calculation, then frequency calculation, then the effect of solvent, temperature, transition state study, and final is decomposition of NH-bond. First is optimization of geometry. We first draw all the reactant, product, and adduct structures in Gauss view, and then calculate, first optimize in at the level of B3LYP 6-311G DP in Gaussian 16 program. After optimizing geometry, we found that there is no imaginary frequency in the optimized output file. So it is confirmed that it has a stationary point and has minimum energy. Geometry optimization of the reactant, adduct, and product was first carried out in gas phase and then under different solvent conditions like water, acetonitrile, THF on the above basis set, as well as the different temperatures I discussed earlier. Next. Then homolumous study. Homolumous study helps to predict the electrophilicity and nucleophilicity of diene and dienophile. Here is the homolumo diagrams of the different reactants. First A is representing hexafluorotubetane. B is representing the monosubstituted furan with NH2 substituent. Third is OCS3 substituent, and fourth is OTMS substituent, and last one is with NH-BOC substituent attached to furan. Here we can see the homo-LUMO gap between these and the energy gap between the homo-LUMO. Here we can see that the hexafluorobutyne HOMO energy is very low. It has the greatest ability to donate the electrons, and furan has low HOMO energy. It has the ability to gain the electrons. This is what expected, as substituted furan is more nucleophile than hexafluorobutyne is more electrophile. The electron accepting ability of hexafluorobutyne is more in gaseous phase as compared to other solvent conditions like acetonitrile, THF, and water, and maximum in THF than acetonitrile. The electron donating ability of substituted furan is in the order of maximum donating ability of substituted furan is in NH2, then OTMS, then NH-BOC, and then OCS3. Now, then I calculate the global electrophilicity power delta omega for the studied reaction. Here is a table shows the global electrophilicity power delta omega. As we can see, 1 plus 2C has greatest global electrophilicity power delta omega, and it is well known the delta omega is greater than 3, then it is the most polar reaction. And the lowest value for delta omega is for 1 plus 2D. It means it is the least polar reaction or all the Diels-Alder reaction. Next is thermodynamic study. Thermodynamic effect of solvent. The Gibbs free energy of the overall reactions as according to scheme was calculated at 290 room temperature at 1 atmosphere at the basis set B3 LYB 311 GDP. In gaseous phase as well as in different solvent conditions. The change in Gibbs energy for the formation of adduct and product was endothermic and exothermic respectively for all the temperature conditions and solvent conditions. The reaction was found to be more spontaneous for the NH2 substituent under all the reaction conditions. And the most feasibility or spontaneous for the NH2 substituent in the gas phase, then water, then THF, and then acetonitrile. In gas phase, the trend in the change in Gibbs energy for the various substituent on furan was found to be NH2, NH-BOC, then OCS3 substituent, and then OTMS last. This trend was found to be different with in solvent conditions. Here is the solvent conditions. NH2 is maximum spontaneous reaction, then OCS3, then OTMS, and then last is NH-BOC. This is the diagram graph of different reactant, adduct, and product. Here we can see as we going to 1 plus 2A to 3D, the energy increases. It means the formation of adduct, the Gibbs free energy change for the formation adduct is positive. It is not the spontaneous reaction. It takes some energy to convert the reactant into adduct. And then we can see we are going to adduct to reactant. The reaction of product is less and the delta G for the reaction is negative. So we can say it is the most spontaneous reaction for all the products, converting adduct to product.
Only 1 minute left.
Yes, sir.
Only 1 minute left. We have only
Effect of temperature, we have studied the Gibbs free energy change at different temperatures, and we can found as we increasing the temperature, the change of Gibbs free energy for the formation of adduct continuously increases. The formation of adduct become less spontaneous at the temperature increase. It was observed in the Gibbs free energy for the formation of 3A to D become more positive with increasing energy. As we can see, overall reaction become less negative on increasing the temperature from 273 to 393 Kelvin. Then we are going to transition state study. We have dry transition state between the hexafluorobutyne and substituted furan and found that the greatest activation energy for the substituent NH-BOC. It means NH-BOC require more amount of energy to convert the reactant into adduct, and then NH2, then OCS3, and the OTMS. Here is the transition states, optimized transition states for the Diels-Alder reaction. As we can see, single bond formation between the diene and dienophile for the all substituents and all transition state are different. These different bond length shows it is the synchronous manner
Time is
mechanism.
up, Shilpa.
Time is up, ma'am.
Sorry sir, I'm not सुना नहीं मैंने क्या बोला.
Many time is up.
Okay.
Your time is up.
Okay. Just a minute. Mechanics study of the reaction here is the mechanics study. Would draw the I1 as an intermediate, it converts into I1 dash. But we draw the another mechanism. This is the I2. It converts into NH-BOG and with 4A, 5 and 6. If it is the NH-BOG, then it may be converted into 4D and or maybe converted into 4A, 5 and 6, but we observed that I2 is converted into 4A, not the 4D. So it is observed that the intermediate is not directly converted into 4D, it converts into 4A. The 4D is least stable as room temperature. The conclusion, last is concluded, Diels-Alder reaction of hexafluorotubutane and substituted furan is endothermic reaction for adduct and exothermic reaction for product and spontaneous for all the substituents. At low temperature, the formation, product formation decomposition of NH-BOG was equally favorable. However, high temperature decomposition of NH-BOG intermediate was thermodynamically much more favorable. And these are reference. Thank you.
Thank you, Shilpa, for your presentation. Are there any questions from the participants? There are no questions. Thank you so much, Shilpa, once again.
Thank you.
Next, we have Mansi. Mansi, are you there?
Yes, ma'am.
Okay. So, Mansi, the rules are like you get 8 minutes for presentation. After 7 minutes, there will be a reminder. And after 8 minutes, the bell will go. And you have 2
Okay.
minutes for interjection. Okay?
Okay, ma'am.
Please start. Please change it to full screen mode.
Yes, ma'am. Yes. So my title of the presentation is In Silico Screening of, ma'am, one second. In silico screening and synthesis and in vitro studies of novel heteroaryl functionalized diacumarol derivatives. So first we have introduction. What are benzopyrene derivatives? Benzopyrene are bicyclic heterocyclic organic compounds that are formed by the fusion of a benzene ring with a heterocyclic pyrene ring with a ketone group. So basically we have two benzopyrones, coumarin and chromone. Coumarin are the derivative which have benzopyrene substituted with an oxo group at the 2 position of the pyrening, while chromone is having oxo group at the position of 4. Coumarins are colorless crystalline solid with a sweet vanilla odor and a bitter taste, while chromone are basically very vibrant in colors. 4-hydroxycoumarin is the moiety of our interest. It is the basic major fragment of several natural and synthetic benzopyrones. It is having versatile biological range. And then we have diacumarol. Diacumarol is having wide spectrum of biological activities and therapeutic potential, such as free radical scavenger, anticoagulant, cytotoxic, antibacterial, antiviral. These are 12 diacumarols derivative which we have synthesized. So this is the basic methodology I have opt for the paper. First we have taken diacumarols. Then we have performed molecular docking and ADME studies with PDB ID of 2W9S, 2EX6 and PDB ID 1FIQ. Then we have synthesized these 12 best derivatives using NPTSA as a green catalyst, and then characterization were performed. And then in vitro studies such as antibacterial assay, enzyme inhibition and antioxidant activity. Then we have also performed molecular dynamic simulation It is a bridge between in silico and experimental studies. So we have used GROMEX for these. Now, what is drug likeness and bioactivity score? These are the important features for the development of bioactive compounds in medical treatment. Drug likeness parameters such as TPSA, log P molecular weight, number of atom rotatable bond, all these are accordingly Lipinski rule of 5. These these are the permissible limit of all the drug likeliness parameters. As we can see, all these are in the factor of 5. Hence, it is known as Lipinski rule of 5. And these are the permissible limit of the for bioactivity. For my derivatives, these are the physiochemical and pharmacokinetic parameters calculated according to the Lipinski rule of 5. So we can say all my derivatives had shown good oral bioavailability except E, F, and H ligand, which have shown one violation, while G ligand has 2 violations to the Lipinski rule. While these 1 or 2 violations are always allowed. Bioactivity score parameters, all these all my ligands had shown good bioactivity score in and they have fallen in the range of moderately active in the range of -5 to 0.0. Then I have performed molecular docking. It is used to determine the binding mode of the ligands within the active site of the protein. So for this, we have choose Autodoc 4.2, BioVia Discovery Studio, and Chemdro Professional. These are the steps involved in my molecular docking. First is the target preparation. In this, we have downloaded all the PDB ID from the RCSB protein data bank, such as 2W9S, E. coli for SORS, for E. coli 2EX6, and for xanthine oxidase inhibition, we have downloaded 1FIQ. All the solvent system and water molecules were removed, while Coleman charges and polar hydrogens were added to the protein. Then for ligand preparation, we have used Chemdro and BioVia Discovery Studio, and then grid generation and visualization of protein ligand complexes were done with the help of Autodoc 4.2, and 10 genetic algorithms were applied. Now, why we have chosen 2W9X 9S? 2W9S is the protein which have SORS S1 DHFR in complex with trimethoprim. What is DHFR? DHFR is responsible for mainly NADPH dependent reduction of 5,6-dihydrofolate to 5,6,7,8 tetrahydrofolate. It is essential cofactor in the synthesis of purine, methionine, and other key metabolites. TMP is well-known inhibitor of bacterial DHFR. This is the active site of 2W9S protein. And 2EX6 denotes crystal structure of penicillin binding protein PB4 from E. coli. PBPs play a key role in antibiotic resistance, and they have also involved in the cell wall formation as well the maintenance of the cell wall. This is the active site for 2EX, and these are the binding energies of our ligand. These are shown very good interacting capability with both of the proteins, E. coli as well as SORS. And we have compared all these binding energies with a binding energy of chloramphenicol, which is a good non-antibacterial drug. And this is the interaction 3D and 2D interaction diagram of 3A ligand, while this is the 3D and 2D interaction diagram of chloramphenicol with SORS. And this is the 3D interaction diagram with 3EC of E. coli and chloramphenicol with E. coli. Here you can see different type of conventional bond, carbon, hydrogen, and pi sigma bonds were formed with different amino acids. Then we have performed xanthine oxidase inhibition activity, and for which we have chosen 1FIQ PDB. And 1FIQ PDB denotes the crystal structure of xanthine oxidase from bovine milk. It is a flavoprotein enzyme that that catalyzes the conversion of xanthine and hypoxanthine to uric acid. Uric acid generally, if it increases, it can lead to hyperuricemia, which is a key factor in the development of gout, as well as uncontrolled reactive oxygen species, which can cause cardiovascular disorders, inflammatory diseases, hypertensive disorder, and hyperglycemia. Allopurinol is commonly used in medicinal practice for xanthine oxidase inhibitor. So this is what allopurinol does. Allopurinol inhibits the xanthine oxidase enzyme, so it cannot catalyze. So it cannot catalyze the reaction between xanthine to uric acid.
Your time is up.
These are the binding energy score of my ligands with 1FIQ. Here we can see 3I derivative has the highest binding energy of minus 12.25 kilocalorie. This is the
time is up.
Yes, ma'am, I'm finishing. This is the 3D and 2D diagram of my 3I ligand, which is the best with 1FIQ. Then we have synthesized the dicumarol derivative, for which we have, it is a very simple procedure in which we have taken 2 millimole of hydroxycumbrine with the suitable catalyst, such as aqueous sodium PTSA, and we have synthesized all these 12 derivatives. We have also performed recyclability test on sodium PTS, and we found it can reused at least 5 times with only a small dip in the product yields. Then we have performed in vitro studies. In vitro studies, we have performed 3 in vitro studies: antioxidant, antibacterial, and enzyme inhibition study. This is the DPPH antioxidant study for our ligand. It can seen with highly all my derivative are highly active, such as 3B, 3I, and 3L have shown good IC50 values, and same for the H2O2 antioxidant activity. Here 3I and 3G were highly active against this antioxidant. Then we have performed antibacterial studies via reazurin based microtiter dilution assay. In this, reazurin dye, blue dye is used, and this is the result. We have got antibacterial response against E. coli rosetta strain. These are the MIC values. Here we can see 3A to 3L, all the derivatives have shown very good activity against. Then we have performed xanthine oxidase enzyme inhibition assay, and in this we can see 3I and a novel derivative 3B, which is highly active and as well as comparable to the standard drug allopurinol in the manner of IC50 value. Then we have then we have performed molecular dynamic simulation, and for this we have used Gromex software. Why Gromex? It is a very simple non-commercial.
Your time
And
is up.
yes, ma'am, just finished.
You have exceeded your time already.
Yes, ma'am. It is very simple, and so for MD simulation, we have chosen 3A, B, and L for antibacterial, and for xanthine oxidase enzyme inhibition, we have selected 3A, B, I derivative for MD simulation. And these are the results we have got. We can see all the results were comparable with the molecular docking as well as MD simulation. And these are the RMSD graphs. We can see very slight variation were in the RMSD, as well as quite similar fluctuation in the protein as well as all the ligands. And we can see high number of hydrogen bonds were formed. So we can see say all the derivatives were highly active against antibacterial and as well as enzyme inhibition assay. Thank you.
Any questions from the participants? Okay, since there are no questions we'll move on to the next presenter, Mr. Neeraj Sagwan. Neeraj, are you there?
Yes, ma'am. It's me, Neeraj Sangwan.
Okay, I'm sorry, Neeraj.
Am I audible, ma'am?
Yes, yes, you are audible. You can please start your presentation. You get 8 minutes for presentation and 2 minutes for interjection. Okay. After
Okay,
7
ma'am.
minutes, there'll be a reminder for 1 minute, and then you finish at 8 minutes. 2
Okay,
minutes for interjection. Okay. Yeah.
Okay, ma'am.
Please start.
Okay, ma'am. Is my screen visible, ma'am? Ma'am?
Please
Is
change
visible,
into
visible.
presenters mode, full screen mode. Please change it to full screen mode.
Yes, ma'am.
On the top, there is a icon for the slideshow. Just
Yes,
go on the
ma'am.
top.
Yes, ma'am. Light show. There is some difficulty. There is.
Set. Okay.
Left hand side. Yeah, yeah. From the beginning.
Ma'am, may I start on this?
Yeah, please continue. No problem.
Okay, ma'am. Ma'am, my topic for presentation is prevalence of dental fluorosis amongst school children of rural areas of Ghana block. First of all, good evening to all. And I'm Neeraj Sangwan from Baba Masnath University, Rohtak. And my topic, it's on fluoride. Because of high concentration of fluoride in the water level, it causes fluorosis. And my slides are showing about this. These firstly start with the introduction. As we know, only a small fraction, about 3%, is the fresh water, and more than 1 million people in the world lack access to safe drinking water. Estimated that 4,000 to 6,000 children dying per day from disease associated with unsafe drinking water. And India support more than 16% of the world population with only 4% of the world freshwater sources. And these are some slides showing in India, about 85% rural population depend upon groundwater, which is depleting at a fast rate. And according the high fluoride, salinity, and arsenic content in the groundwater are the major chemical related problems of the India. And according to WHO, fluoride and arsenic in the drinking water are the most significant hazards to our life nowadays. Uh, next slide, moving to next slide, we are discussing the bad effects of fluoride. And because of fluoride, uh, there is a disease called fluorosis. Fluorosis is a disease caused by the deposition of fluoride in the hard and soft tissues of the body. And it is not merely caused by the excess intake of fluoride, but there are many other attributes and variables which determine the onset of fluorosis in human population. It is usually characterized by discoloration of teeth and crippling disorders. And drinking water contribute mainly 70 to 90% of daily intake of fluoride. And presence of fluoride up to 1 milligram per liter in the drinking water is beneficial for cavity prevention, but only up to 1 milligram. Next, in the next slide, fluoride is the ionic form of element fluorine, the 30th most abundant element in the earth crust. And as we all know, fluoride is negatively charged and the most electronegative element, and combined with the positive ions, and which are calcium and sodium, mainly present in our bones and teeth. So such fluorides are released in the environment, into the environment naturally in both water and air. In humans, fluoride is mainly associated with calcified tissues, as I say, because of electronegativity of fluorine. It mainly bind with electropositive elements. These are calcium and sodium, which are mainly present in bones and teeth, and because of high affinity for calcium and sodium. And moving to the next slide, magnitude of fluorosis. It is worldwide in distribution, endemic in 25 countries. In Asia, India and China are most affected. Mexico in North and Argentina in Latin America, East and North Africa are also endemic. And now we have to discuss fluorosis in India. In 1930, fluoride was discovered in groundwater, and first scientific research paper on this topic was published in 1937. 20 states of India are suffering from excessive fluoride in their groundwater, and 62 million people, including 6 million children, suffer from fluorosis. And mainly Rajasthan and Gujarat in North India and Andhra in South India are the most affected. Punjab, Haryana, Madhya Pradesh, Maharashtra are also moderately affected. Tamil Nadu, West Bengal, UP, Bihar, Assam are mildly affected. And this is a picture showing the intensity of fluorosis. Dark red color showing the highly affected districts, and light pink color showing the fluoride affected district to some extent. So these dark red, they are showing highly affected fluorosis districts. And next moving to the effects of fluoride on human health. As we know, fluoride is also important to us. Fluoride concentration, fluoride concentration, if it is present nil, if it is not present, means it is nil, then there is limited growth and fertility. Growth is not so good. And but if it is less than 0.5, it's also, fluoride is also very important to us. If it is less than 0.5, then it causes dental caries. And if it is present in 0.5 to 1.5, it is very good for us, promotes dental health and prevents tooth decay. But if its range is 1.5 to 4, it causes dental fluorosis, dental mottling and pitting of teeth. If it is 4 to 10, dental plus skeletal fluorosis, pain in also neck, bones and back. If it is more than 10, crippling fluorosis take place. Next, we have to discuss about, mainly we have to discuss two types of fluorosis, dental and skeletal. So first we have to start with dental fluorosis. Dental mainly involves in a male. Mottling is one of the earliest in the most recognizable feature, and it is equally affected. It equally affects the both sexes. Permanent teeth are affected, and pitting and chipping also seen. Chalky white teeth appeared. In endemic areas, dental fluorosis has linear relationship to fluoride content of the water. And these some pictures showing the normal, if we have normal enamel, means fluoride is present in normal range. We have normal enamel. This picture shows, and in this, it is very mild dental fluorosis. Dental fluorosis, further of three types: mild, moderate, and severe. This is normal, and next is very mild. Very fine lines are there in this diagram. Next
1
is
minute का समय.
mild dental fluorosis. Mild dental fluorosis is this is there in this.
You have 1 minute to finish your presentation.
Yes, ma'am. 1 minute.
Yes,
Moderate,
you have 1 minute left.
moderate dental fluorosis, and next is severe dental fluorosis. And next is skeletal fluorosis. Skeletal fluorosis is there is pain and stiffness in back, and there is stiffness in joints, restriction of movement occurs, and mainly men suffer more than women. And skeletal fluorosis begins crippling between 30 to 50 years of age. And these are some pictures showing the skeletal fluorosis. And my discussion, my result is on this topic. I have done a survey on 108 students of age group 12 to 16 for dental fluorosis in Gohana block, and the age and the dental fluorosis was found to be 70%, and approximately 36% of students were suffering from mild, 30.5% from moderate fluorosis, and only 2.8% students were suffering from severe dental fluorosis, and 30.5% of school children were without any dental fluorosis, means they are normal. And this is table showing the study, and this is pie chart showing the severe, mild, nil, and moderate fluorosis.
Time is
And
up.
so we have to eradicate fluoride from our water sources. We have to use such type of water, converting high fluoride water into low fluoride by defluorination techniques. We can use such type of technique. So conclusion is that in this area there is increased prevalence of dental fluorosis, and it is major health risk among school children. So dental regular health checkup and practice of routine oral hygiene procedure will enable them to lead a healthier life. This all about from my side, ma'am. Thank you, ma'am.
Are there any questions from the participants? There are no questions. We move on to the next participant.
Thanks, ma'am.
Mohammada Malik. Are you there?
Yeah, ma'am. Yeah, ma'am. I'm there.
Good evening. You have
Good
8
evening, ma'am.
minutes to do your presentation. After 7 minutes, there will be one reminder for 1 minute remaining, and you have to finish in 8 minutes. There will be 2 minutes for interjection. Okay?
Yes,
Please
ma'am.
start your
Thank you, ma'am.
presentation.
For you. My name is Mohammad Abrar Malik, myself, from the Department of Industrial Chemistry, VPN RPTP Science College, Vallabh Vidyanagar, Sardar Patel University. For the today's
थोड़ा
topic
सा
on...
तेज बोलेंगे,
Yes,
आवाज
ma'am.
आपकी कम आ रही है.
Yes, ma'am. I'm speaking loudly. The today's topic is the hydroxyl terminated dendrimers for the remediation of copper plus 2 ion, nickel plus 2 ion, and zinc metal ion from the aqueous solutions. These are the contents of my presentation today's over here. The first one is the introduction of dendrimers, how they are synthesized, the general scheme which I have synthesized, then the metal remediation and their characterization of the dendrimers. See, first of all, the dendrimer were introduced in the 1980 by the D.A. Tomalia and Pratchett. These are the some particular diagrams which we are seeing in the this slide, that this dendrimer are the tree-like structure. Then this dendrimer generally roots from the Greek words dendri and mer, which means the dendrimer. Moving for the second slide, it is clearly seen. Oh, sorry. It is clear why how the structure of dendrimer works and how the structure of dendrimer, if this synthesize, will be there. From the center of point of view, it is binding with the core, then the branching units, generations, the terminal functional groups, and the dendrons. By these complications, we can go to the generation from core to generation by adding the branching units to generation to the other units and units. This is the properties of dendrimer, which can be seen in this table. The structure, synthesis, structural control, architecture, their shape, crystallinities, their solubility, their non-polar solubility, viscosity, in compared to the linear polymers. We can see over here that the dendrimer, why dendrimer is more popular than the linear polymers is over here, that they are the compact and globular structure that linear polymers doesn't have. Second is the synthesis. careful and stepwise growth of the synthesis are there, which can be see in the next slides. And the the polycondensation, the polymerization is in single step normally.
To present my research paper.
The structural control is very
As we
high. Hello, yes. The structural control of the dendrimer is very high, thus the linear polymers is very low. The architecture is very regular, and the linear polymers have the irregular. Shape is spherical, random scale, and crystallinity or amorphous material is very high. The lower glass temperature does the dendrimer have, while the linear polymer have semi, mild, and other dendrimers is very high. The aqueous solubility, which is very important to the dendrimers, is very
good evening
high.
to all of you. I'm Sunita. I'm Sunita, research school.
See,
Papa
Please mute yourself, please. Somebody is unmute. Please
yeah,
mute yourself.
somebody is interpreting.
The participant is being disturbed. Please mute yourself.
See, this one of the types and the applications which our dendrimer have. Particularly, we can have the dendrimers from the PAMAM, that is PAMAM dendrimer, PAMOS dendrimer, PPI dendrimer, triazine dendrimer, chiral dendrimers, and hybrid dendrimer. One of that, I have synthesized the triazine-based dendrimer, and on the second right side picture is showed that how this dendrimer are using in the application point of view in the 21st century. These are the most these are using most of it. Most of the biomedical applications, environmental drug delivery, targeted drug delivery, catalysis, harvesting, transfer, biomimic, MRI, gene delivery, artificial enzymes, various types of whatever you want to do with these dendrimers, you can get that application. How now the synthesis point of view, how the dendrimers are generated. First of all, the core is there, and the second the core is there, and by the addition of the generation or monomers, we can see over here that the red one is the core and the blue one is the monomer. By addition of the stepwise growth to monomer to the core, the generation will grow more and more. Here we can see over here from the grow G0 to G3 is synthesized. The most common dendrimer synthesis pathways are two. The one is the divergent and second one is the convergent. In the divergent synthesis point of view, we can see over here in the picture, the monomers are directly covalent by the bonding of covalent to the core, and the generation growth, the stepwise growth of the generation is carried out. While you can see over in the second synthesis route, this is which is convergent, in which the core is there, but the addition of the monomer to monomer will be attached to directly the core, and the dendrimer will be generation. Dendrimer will be synthesized. Here I have choose the divergent growth, which is very easy to generate and synthesize a dendrimer, and while the convergent point synthesis point of view, which is yield is low, and this is very difficult to synthesize a dendrimer. But it is there. Fratchet has generated the PPI dendrimers. Now, I have synthesized the triazine-based dendrimer using the homopiperazine, which we can see over here that this is the simplest and easiest way to synthesize a dendrimer. Here is the reaction scheme which I have gone through to synthesize a dendrimer. In this picture, you can see over here this synthesized triazine-based dendrimer hydroxyl are there, in which these dendrimers are firstly converted into solid to liquid stepwise. We can see over here in this reaction scheme, but first of all, diamine and cyanide chloride is merged in the 0 to 5 degrees centigrade in the system of DCM and water. Then the core 0.5 generation is there. Then after the generation is there, generated, it is refluxed with diethyl amine at 170 to 180 degrees centigrade to have Z1 dendrimer. Then again, we are using the 0 to DCM and water and ice system to generate 0.5. Then generation 2 is there, repeating that with diethyl amine refluxing. Then the further reaction is carried out to generate generation 2.5 with cyanide chloride and DCM. And after that, we have the generation 3 dendrimer, which you can see over the half generation, which has indicated as 0.5, 1.5, and 2.5 are solid materials, while the 1, 2, and generation 3 are the liquid materials, which are very useful in this particular
Only
area
1
of
minute left,
biomedical
sir.
application. Yes, sir. Yes, sir. This is the physical properties of dendrimers, which I have synthesized. Core generations, their molecular formula, their physicality, their water solubility, and their functional groups, which are attached to them. So, which I have carried out this metal uptake, metal imitation ion is over here, is the aqueous solution of the dendrimer is directly merged with and dispersed with the metal ion solution separately in the pH of 4, 7, and 9.2, and using at the 25 degrees centigrade for 24 hours. And the titration is carried out with the DTA solution. Here is the graphical illustration of the metal ion uptake remediation. This is the procedure which I have carried out for this type, metal uptake removal. These are the results which I have got from the generation 1, generation 2, and generation 3. As the generation 1, generation 2, generation 3 is grow up, the hydroxyl molecule, hydroxyl functional group. Yeah. The generation, the hydroxyl group, hydroxyl ion is there at the periphery of the dendrimer generation. As the generation increase from 1 to 2, the metal uptake ion is, we can see over here, it increasing. These are the this is for the time of contact time, 6 hour, 12 hour, 18, and 24. This is for the generation dendrimer at the pH for the molecular ions. These are the results for the metal uptake ion dendrimer generation 3 to 1 to 3. This one is the generation absorption capacity of the generation to generation. How the at 9.8 we have got the metal ion absorbed in our particular in our dendrimers at 9.2 pH. This is the metal and this is the illustration of that particular dendrimer, which we can see that the copper plus ion, nickel plus ion, and xenon plus ion is absorbed, but due to their electronegativity, the copper is highly absorbed than the nickel and the zinc. These are the metal uptake ions of FPIR, which we can carried out. These are the TGA, and these are the TGA carried out at the from 100 degree to 600 degree temperature, which can at the 600 we can see that the 8.42, 8.24, and 3.16 is the metal oxides is remaining over there, which indicates the presence of metal uptake metal ion in our dendrimer generation 3. And these were the conclusions which we can carried out for the dendrimer generations, that these dendrimers can be easily useful to remediate the metal ions from the aqueous solution, and the rest water from rest waters is there. Thank you.
Any questions from the participants? Okay, there are no questions. Thank you, Malik, for your presentation. Next, we move to Shreyansh. Shreyansh, are you there?
Yes, ma'am, I'm here.
Okay.
Yeah.
So, Shreyansh, you will get 8 minutes for your presentation and 2 minutes for interjection. After 7 minutes, there'll be a ring to tell you that 1 minute remains. Okay?
Sure, ma'am, sure. Ma'am, is the screen visible? Okay, I'm starting right now. Good afternoon, everyone present here. My name is Shreyash Kadam. So, moving to the introduction slide. The main reason behind selecting the nitrogen containing heterocycles are primarily the exceptional role of nitrogen forming variable interactions with biological targets by offering high degree of structural diversity. These N heterocycles display a wide range of pharmacological activities such as anti-cancer, anti-HIV, anti-malarial, antimicrobial, etc., which broadens the scope of drug development. The image shown displays the amount of work done on N heterocycles between 2009 to 2020, that is 11 years of span. And we can see the trends of research interest is growing in this area by the passing of time. So currently the various drugs used in clinical treatment have been extensively used in treatment of various types of diseases with high therapeutic potency, resulting in development of multi-drug resistance. Also, various infectious diseases are emerging, out of which cancer is a major disease all over the world, and its treatment is significant trouble for clinicians. So by literature review, we have observed that heterocycles such as thiazolidinone have been targeting various cancers and showing good results, due to which we have decided to develop novel moieties containing this heterocycle, which we will provide structure diversity and improve binding interactions, resulting in treatment of cancer. In addition to this, there are also various advantages of this, such as easy preparation, low toxicity, less adverse effects, low drug resistant, high bioavailability, and better biocompatibility. Here is the objective of our research work, where firstly we have synthesized novel fluorinated thiazolidine derivative, later characterized them through NMR and IR spectroscopy, after which we focused on the application part of these compounds by performing in silico molecular docking evaluation. Now discussing the basic introduction of thiazolidinone. They are the oxo derivatives of thiazolidine, which belong to an important group of heterocyclic compound containing sulfur and nitrogen, as well as carbonyl group in fourth position in a 5-membered ring. 3 derivatives depending upon the position of carbonyl groups are shown here. It provides versatile scope of chemistry by attaching groups to the carbon atoms in 2, 3, and 5 position of thiazolidinone ring, which broadens the scope of drug development. Thiazolidinone gives out various derivatives which attracted great attention due to the diversity of biological effects. These are the biological activities which the heterocycle is targeting. These are the previously synthesized drugs. Now moving to the actual synth part. Now the scheme for the preparation of fluorinated thiazolidine derivatives. Firstly, various anilines and chloroacetyl were added in the cooling condition and reacted at room temperature in DCM. We also added 2 to 3 drops of DMF as a catalyst. Later resulted the acetamide intermediate was again reacted with ammonium thiocyanate in the basic condition in reflux medium to yield fluorinated thiazolidine derivatives. Below mentioned are the 5 synthesized novel derivatives. Now discussing the proton NMR, the aromatic proton A showed the singlet of 2 protons at 7.95 ppm. The aromatic proton, the ring proton C was observed at 4.15 ppm, that gave singlet of 2 proton, and lastly the NH proton was observed at 12.39 ppm, that showed a singlet. Here is the IR spectrum of the where the peak at 1730 centimeter inverse was due to the carbonyl group. Later, the NH bending was observed from 1594 to 1614 centimeter inverse, 40 centimeter inverse. Later, stretching around 8712 centimeter inverse. Lastly, the aromatic stretching was observed around 3072 centimeter inverse. That confirmed the presence of functional groups. This is the another proton NMR of one of the representative compound, like shown is the image that represented the 3,5-CF3 compound. This is similar IR spectrum that showed the carbonyl frequency around 1733 and NH bending around 1580. Now moving to the application part, we have analyzed the potential of synthesized derivatives with the help of molecular docking technique. The shown is the protein molecule used during the study. The protein used is the c-KIT tyrosine kinase protein. The computational molecular docking techniques methods are used to screen variety of possible compounds, searching of new compounds with the specific binding properties, or testing a range of modification of the existing compound. Due to the rapid rise in the amount of molecular biological data available, The computer-aided analysis of molecular interaction become more realistic. In addition to which, as of now, the computer prediction of interaction between receptor protein, which are the prime targets for therapeutic agents, and ligands or small molecules has advanced to the point that it allows accurate prediction of bound conformations and affinities.
1 minute left, sir.
Okay, sir. Okay. Here is the process. Firstly, we have prepared the protein and ligand. Then we have later move on to in the MGL2 software where the remaining protein has been prepared. Finally, the docking was done with the help of Autodoc Vina, and we found 9 poses, out of which the lowest affinity value was selected as the best docking pose. Here is the result of the synthesized 3,5-CF3 compound based off the hydrogen derivative, which has undergone the docking. Total 17 favorable interactions were observed, where ligand has bounded at the chosen pocket site in the selected pose. Output shown here is the 2D and 3D interactions. The interactions observed were 1 hydrogen bond, 3 halogen bond, and 13 hydrophobic interactions, that is pi sigma alkyl and pi alkyl bonds. Finally, we have planned in future to perform anti-cancer and antioxidant activity on the synthesized derivatives. These are the references. Thank you.
And thank you, Shreyansh. Any questions? Okay, thank you so much. We move to the next participant, Pankaj Kumar Bhatt. Is he there? Pankaj
Yes,
Kumar?
ma'am. I am Rutva Bhatt, Rutva Pankaj Kumar Bhatt. So I am here. Yes, ma'am. I'll be sharing the screen.
Yeah, please share your screen. You have 8 minutes time and 2 minutes for interjection. Please start.
Okay, ma'am. Got it. Is my screen visible?
Yeah, please change it to full screen mode. Yeah,
Yeah, done.
yeah, please.
Okay. So good evening to one and all present here. I am Rutva Bhatt from Navrachna University, Gujarat, and today my topic of presentation is about the synthesis of triazole-based benzene derivatives. Okay, so the triazole, as the name suggests, it's a heterocycle, and definitely it contains the 3 nitrogen atoms and 2 carbon atoms. It's just a 5-member ring, and there are like the triazole. The name was first coined by Bladin in 1855. And triazole is like has 2 types. There are 2 types of triazole, which is 1,2,3 triazole and 1,2,4 triazole. Triazoles, like they are quite known for the performance of the anti-cancer activity, and it plays quite a significant role in the medicinal chemistry. There are triazole have many kind of properties like that of anti-cancer, antiviral, anti-inflammatory, anti-diabetic, antioxidant. So they are quite the molecule of interest these days. Also, despite of the advancement in the case of the anti-cancer drugs, there is a need to develop certain kind of drugs that are quite safer, like that reduces the unwanted side effects. Like we are very much familiar with the side effects of the cancer drugs, like that of hair fall, then liver damage, kidney damage, and many more such side effects. So there arises a need to develop the safe drug for the cancer when it comes to the cancer treatment. And also the cancer is the second leading cause of death after the cardiovascular disease. 1,2,3 triazoles, however, are such a stable compounds, and they interact with the biological targets by forming hydrogen bonds, and they are also known to have exert anti-cancer effects by inhibiting the enzymes. We are very much familiar with the click chemistry given by the K. Barry Sharpless and the copper catalyzed click chemistry. It's just about the azide and alkyne. There is azide moiety and an alkyne moiety. They undergo the click chemistry to form the 1,2,3 triazoles. Copper, in the presence of copper plus 1, it selectively forms the 1,2,3 triazole. So here are the biological activities of the triazole group. Like you can see, it's the antiviral. It shows antiviral activity, anti-cancer, anti-tubercular, antioxidant, even antidepressant and anti-inflammatory, analgesic when it comes to the painkiller things, and antimicrobial. Okay, so my objective of the study was to synthesize like a novel triazole-based derivatives that are not known previously, and to characterize them, and then to perform the molecular docking studies. Here is the methodology wherein I have prepared the triazole derivatives like by just basically using hydroquinone as a starting material and then just reacting it with 1,4-dibromobutane. And then later on replacing the bromo group with the azide group. And then I have carried out the click chemistry. So here are the synthesized derivatives from A, B, and C. Okay, so this is the analysis part, which is the proton NMR. At like you can see that here the benzene ring. So the proton is the the A1. You can see over here in this aromatic region, that is at 6.796 ppm. You can see the aromatic ring proton, and at 4.539, 4.521, and 4.503, you can see the triplet that is of the E proton of this alkyl chain. The p proton over here of this alkyne chain can be, you can see it at 3.926, 3.941, and 3.956 ppm, and it's a triplet. And even the protons D and C, they form the quintet, and it's can be seen at 2.118, 2.136, 2.115, 2.173, and 2.191 ppm. For the C, it's present at 1.757, 1.772, 1.788, 1.794, and 1.809 ppm. Now moving towards the proton of this triazole aromatic ring, you can see it in the aromatic region, the S proton over here, it's at 8.139 ppm. And also the ethyl group protons are present at G and H in the aliphatic region. Okay, so computational studies like that of molecular docking are very much necessary, like in order to like predict whether the synthesized molecule is reacting with the protein or the receptor that is the target. So that arises a need of performing such studies instead of just blindly going towards the application part. So this is quite of cost effective, and resources and materials are not wasted. So you can always perform molecular docking beforehand. So the protein I have used is the 1T46 protein, tyrosine protein kinase, and it acts well as the cell surface receptor for the cytokine and plays an essential role when it comes to the regulation of cell survival, proliferation, and stem cell maintenance and all. That's why this protein was my target. I had performed the docking with one of my known compound, and I had this is the 3D representation and the 2D representation, and here are the affinity values. 7.1, one of the pose was found to be exhibiting the affinity value of -7.1. And you can see over here where various kind of interactions are visible, like that of the van der Waals forces of interaction, hydrogen bonding, and like and many more. So we had like 3 hydrogen bondings, and the remaining 5
Only
were the
1 minute left,
hydrophobic
ma'am.
interactions. Yeah, sure. So future perspectives, so we plan on to perform the in vitro anti-cancer activity, and even I will try for the antioxidant evaluation. These are the references. Thank you.
Thank you, Rutva. Any questions from the participants? Okay, the next presenter is Denita.
Yeah, yes, ma'am.
Okay. You get 8 minutes for your presentation. After 7 minutes, there will be a reminder bell and you will have 2 minutes for interjection. Okay.
Okay, ma'am.
Please start.
Is this my screen is visible, ma'am?
Yeah, yeah.
Yeah. Good evening, on and all. I'm Denita from Ahmed University, Chennai. Here I'm going to explain the method of formal analysis of Brato type equation in electrospinning process using Akbari-Kanji method. And before going to the method, I'm going to explain what is the mathematical modeling. Because of these, from this only, we deduce that Akbari-Kanji method. And mathematical model is used for abstract model to describe the sum behavior of mathematical terminology. Here we get a theoretical models or we have in chemistry, biology, botany, something that we have to change into mathematical models. So we use these methods to solve the solutions and get the correct solution for the process. Then in mathematical modeling, there is a numerical and analytical solutions. What is numerical means we get some methods to solve it and we get an answer, and analytical means we use a computing software for get a solution. So we have to compare both solutions and we get the similar approximate lines, means it will the problem is correct and accurate answer we get. Here the numerical and analytical solution, it is difficult to convert our problems and equations into simple. So we use this methods to convert that. This method is used in differential equations that is non-linear. What is non-linear means it will have the, we all know differential equations dx by dy, that all. So in the power dx power 1 is that is linear, in power dx square means it is all non-linear. Two or more than variables are there, it is a non-linear problems. So it is difficult to consider because we can find a y dash, but double dash is it is so difficult. So use Maple software or some other computing software. We deduce that some methods are introduced by authors for numerical and analytical solutions, that are Paddy approximation method, Akbari-Kanji method, hyperbolic function method, new homotopy perturbation method. In my paper, I explain electrospinning process. In nanotechnology, the electrospinning process is so well-developed process in physical chemistry, electricity, fluid science, and etc. We prove that this technique is great for nanofiber materials. Nowadays, the nanofiber material is vast in producing. So this nanofiber materials are impact a lots of good important roles in human health issues like skin care, nanofiber materials in plastics, wardrobes, etc. This nanofiber material is get from an electric forces given to that, and there we exist the jet fiber materials. That fiber is it lots of thin fiber. So that nanofiber material produced one solvent flowing jet is evaporate during that electrospinning process. Here the electrospinning process is used in a thermodynamic balancing equation. That equation is called Brato type equation. That Brato type equation is a non-linear equation. So we used mathematical models to solve that equation. Here I used Akbari-Kanji method. This Akbari-Kanji method was proposed by Akbari-Kanji in 2014. So this method is we solve the equation as possible simple. So some other methods are there, but this method is compared to all methods, it will solve easily. So the nonlinear Brato type equation is d square y of x dx square plus lambda e power minus y of x. Here that y is considered as dimensionless temperature and x is considered as distance. That lambda is the Frank-Kaminsky parameter. So the temperature of the lambda is increasing or decreasing. So that only, the lambda only denotes our jet is expelled, evaporates or not. It will come out well or not. So about that lambda only this problem is derived. The boundary conditions are y of 0 equal to 0, y of 1 equal to 0. The asymptotic
methods or Akbari-Kanji methods are y of x equal to y0 plus y1x plus y2 etc. So we use this boundary conditions to derive that y of x, y dash of x, y double dash of x. So from this we apply this equations in this equation. So we get a of x equal to 2y2 plus lambda. From this we get y2, that is unknown parameter. From that y2 we get lambda. So that lambda is going to be considered as in table form or in a graph form. So we consider comparison of dimensionless field. Here the lambda is 0.1 and 0.2. You can see sorry. Yeah, here you can see these are the x values and these are the, we get numerical and analytical solutions. So you can see if I put x equal to 0, then I get 0 and analytical value is also 0. So there is no such variations are there. So same as when lambda equal to 0.2. Here where means lambda equal to 0.2 means the x value is 0 or 1, that will be changed. So that also there is a no average error is considered. While lambda is 0.5 and 0.5 and 1, there is a slight change like a 0.1 percentage error, 0.0 percentage error, that is we consider. So you can see you can normally see when lambda is 0.1, you can see that dark line and dotted line. The dark line are denoted as an analytical solution. The dotted line are denoted as a numerical solution. You can see it. It is very resembling closing to the curves, and we find out that the electrospinning process utilized to create nanofiber materials. When it comes to human health, the electrospinning process is making huge difference. And we use the AGM method to offer a highly accurate and good approximations of nonlinear systems. That AGM method is a very simple and time usage of methods. In computing also, we give programs for electrospinning process. That electrospinning machine is programmed like some
Only one left, ma'am.
lambda equal to some this value, x equal to this value. So this Brato type equation is useful. From this Brato type equation, we used Akbari-Kanji method, means our program will be get more shorter, and the comparison of numerical and analytical solution of Brato type equation resulting in good satisfactory level. Solve this problem to model issues precisely, make the solution possible as possible simple. So here's my references, and thank you.
Any questions from the participants? Okay, as there are no questions, let us thank Denita for her presentation. And now
Thank you.
Sunita Rani. Sunita, are you there? Alpesh is there? Sunita Rani? Alpesh, are you there?
Yes, Alpesh, yes.
Okay, first
Yes, ma'am.
Alpesh and then Sunita Rani, you be ready with your presentation, okay?
Can I
Alpesh,
share my
Alpesh?
presentation?
You have 8 minutes for your presentation. Okay? 2 minutes for interjection. Next, please keep yourselves on mute. Please keep yourselves on mute. Dear participants, please keep yourself on mute. Yes, Alpesh, please start.
Yeah.
You have 8 minutes for the presentation and 2 minutes for interjection. After 7 minutes, there will be a reminder that 1 minute is left. Okay?
Are you visible my presentation?
Please change it to full screen mode.
Okay.
Presentation mode or full screen mode.
Now it is okay.
Yeah, this is okay. Please start.
Myself, Alpesh Shah, Market
Please
University.
be a little louder. You are not audible.
Okay, myself, Alpesh Shah from RK University, Rajkot. I am audible?
Yes, yes.
And my
continue.
title, research title is dibenzylamine as an ammonia surrogate in the UG-tetrazole, design and synthesis of an impactful antioxidant precursors. Abstract. The present work include preparing new compound of tetrazole based on dibenzylamine and using them as antioxidant agent. The mentioned compound were prepared using UG multi-component reaction by stacking four system, that is DPA, cyclohexyl isocyanide, TMSN3, and aromatic aldehyde in ethanol media under RT. The different isocyanide effect in the progress of the trimethylsilineazide based UG reaction was studied. The modified DPA based tetrazole were characterized using different techniques such as FTIR, 1H-NMR, 13, CNMR, and MS. Then the antioxidant activity of the synthesized compound for A2Z were experimentally examined in vitro through the DPPH free radical. The obtained result for all prepared compounds were good as an antioxidant in comparison with ascorbic acid. Introduction. It has been suggested that free radical play a significant role in negative impacting human health by degenerating cells, which can lead to serious disorder including cancer and cardiovascular disease. Substantially, evidence suggests that this chemical cause oxidative damage to biomolecule like lipid, protein, and nucleic acid as a result of their fast relativity with electron acceptor molecular oxygen. They produce radical known as reactive oxygen species. Organic chemistry based nitrogen rich scaffold have been shown to play a significant role in generating a lead to block, kill, or cure the precise target necessary to treat the prevent persistent medical disease and illness. The DBA tetrazole framework could demonstrate antioxidant features and could also interact with the DPPH because of its aromatic character and electron-rich nitrogen system. Continuing with our interest in the design, synthesis, and biological evolution of multifunction molecule, particularly UG-based multi-component reactions, our work is currently focused on taking advantage to build nitrogen-rich isoester of melatonin-based hybrid. So in this work, we have designed new adduct keeping two systems in similar framework, that is DPA, dibenzylamine, and tetrazole using traditional trimethylsilyl based UG for CCR with interesting and complementary properties like single-step procedure and higher yield. This is the reaction scheme which we done and we prepare or 10 different compound with different functional group with this. The two reaction was found in an attempt to perform the azido-UG reaction of DBA and 3-nitrobenzylaldehyde. Corresponding reactant were as a model, that is the use of one isocyanomethyl 1H benzotriazole and 2-morpholinoethyl isocyanide, showing not isolated product 8 and 9. This is the reaction scheme. These two compounds were not converted in as per UG reaction and not formed a tetrazole ring. This is the limitation of this reaction because of various reasons, but negative results were found. The failure with this substance is mostly probably due to lower electrophilicity of intermediate aluminum salt as well as the structural hindrance of this ring. So this is the isocyanate are not converted in tetrazole as per UG reaction. We identify the structure with 1H NMR and 13C NMR. This is the 1H NMR of the compound 1. Here we obtain aromatic proton. This is the proton of from chiral carbon. This is the aliphatic proton obtained in this downstream. As well as we identify the compound with 13C NMR also. This is the aromatic carbon, and here is the aliphatic. We studied antioxidant of this compound in this continuation of our work, and bioactive compound tetrazole were designed, synthesized, and evaluated for their antioxidant as per experimental protocol. After 30 minutes of incubation of the DBPH sample, the solution changed from purple color to yellow in most sample. It indicates reduction of DBPH and implies that the sample has a scavenger effect of a radical DBPH using reference standard as ascorbic acid. The result of the anti-radical power by the DBPH of the sample is shown in below table. This is the result of against ascorbic acid, and all compounds shows good antioxidant activity against DBPH. The flexible motif dibentylamine has been used in our study of the TMSN3 modified UG reaction. It has been demonstrated that the isonitrile plays a more significant role in deriving the reaction forward. In good to high yield, the technique enables the synthesis of 1,5-disubstitute tetrazole derivatives containing various aldehyde fragments. The synthesized tetrazole derivative amines show promising result up to 10% inhibition in comparison to the standard regardless of 0% inhibition of ascorbic acid in DBPH based antioxidant activity. This is our conclusion. Thank you, madam. Thank you very much.
So, are there any questions from the presenter, from the participants? Okay, since there are no questions, thank you, Alpesh ji, for your presentation. Next presenter is Sunita. Mahesh, you be ready.
Yes, ma'am.
Sunita first and Mahesh in waiting.
Yes,
Sunita,
ma'am.
you will get 8 minutes for your presentation. Okay,
Yes, ma'am.
after 7 minutes, there will be a reminder for 1 minute left, and you will get 2 minutes for interjection.
Okay, ma'am.
Okay.
Good evening to all of you. My topic on based on access thermodynamic investigation of binary mixtures involving methyl urate and hexane to all at
Slides
various
are not
temperatures.
visible.
Your slides
Uh,
are not visible. Please share your slides first.
मैम मैंने तो शेयर कर रखा है.
आपकी स्लाइड नहीं दिख रही है सुनीता.
मैम मैंने तो शेयर कर रखी है स्लाइड्स.
किरण कुछ ऐसे.
Have you put off your slides from the stop sharing? Alpesh. Who left?
Ma'am, my slide is visible or not?
No, no, your slides are not visible.
Now?
No, no, no.
Please share your screen. Huh? You know now how to share.
Kiran, need.
Yes, ma'am. Just please.
नीता नीचे एक बटन दिख रहा है आपको एरो आपका, उसको हिट करेंगे आप तो स्क्रीन शेयर कर सकते हैं. आपने उसको हिट किया था?
मैम एरो कहाँ पे?
आपकी स्क्रीन
On the bottom side, you can see the green icon is there. Share screen.
Yes, ma'am. Share screen. Share screen. Then I will choose screen.
And now open your desktop. Minimize this Zoom screen.
Yes,
and
ma'am. मैम मेरा डेस्कटॉप ओपन है, मेरे को स्क्रीन दिखाई दे रही है. ये शो कर रहा है मैम. योर स्क्रीन इज शेयर इज लोडिंग.
I think then your network issue, maybe your network issue.
Ma'am, then what will I do? Excuse me, ma'am. Then what should I do? My screen share is loading. Mention on my screen.
Sunita, I think there is a network issue on your side. Kiran, क्या कर सकते हैं? Can we go to the next participant and we will take her after the presentation is over? Kiran?
Is there any problem, ma'am?
Beta, the participant की ना screen sharing हो रही है ना, that we are not able to see the screen. She's sharing her screen, but we can't. Now it is visible, Sunita. Now it is visible.
हाँ हाँ, thank you, हो गई visible, हो गई.
आप इसको full screen mode में डाल दीजिए. Presentation mode में.
At least you should join on your name, na. That's why administrator is not allowing you to show your presentation.
Okay. Now I will start, ma'am.
Yes, please start. Please start. Change it to full screen mode.
Yes, full screen.
Please go ahead.
Yes, ma'am. नहीं हो रहा है. My topic based on access thermodynamic investigation of binary mixtures involving methyl urate and hexane 2-ol at various temperatures. Now we will discuss about, as we know, environment problems such as air pollution, water pollution, and noise pollution are nowadays very serious problem for our planet. The main cause of environmental pollution is combustion of fossil fuels, coal, petroleum, and natural gases. So it is very large requirement to develop a new fuel that stinks completely and releases less fewer toxic pollutions. Biofuels are an alternate fuel for diesel engines that is non-toxic, biodegradable, and renewable. The thermodynamic properties of liquid mixtures and pure liquids are of interest to both chemists and engineers. For processing of pharmaceutical products and engineering designing involving chemical separation and fluid flow heat transfer to improve the quality of biodiesels, reduce the negative influence, such as alcohols can be used as blend components to produce biodiesel alcohols, composing in several proportions because of their miscibility and biodiesel. Adding alcohols to form biodiesel alcohol blend is significant for theoretical and experimental study, which will make available information about the molecular interactions, such structure of molecules and difference in size. In present work, excess molar volume, excess isentropic compressibility were calculated over the whole mole fraction at various temperatures by using their densities and speed of sound values and then fitted in Radley-Fisher equations. The material that I used, methyl urate and hexane 2-ol, were purchased by Sigma, Aldrich, and TCI. All samples were used without purifications, and I measured densities and speed of sound by using the experimental values that using the instrument DSA, density sound analyzer, and then the using of these values, density and speed of sound, I calculate excess isentropic compressibility and excess molar volume. Now we will discuss about the discussion and results, which that I calculate density and excess speed of sound. First, I use the values of density. I calculate excess molar volume. Here, the excess molar volume for binary mixtures involving methyl urate and hexane 2-ol were calculated by using their densities, by using this equation. Here, xi is mole fraction, and these are the densities of binary mixtures, and mi is the molecular mass of components. Here, the calculated excess molar volume has been fitted to Radley-Fisher equations because it provides algebraic representation of thermodynamic properties. And if we can see, xi and xj are represent the mole fractions which I used, and equation 2 using for the parameters, the values of parameter for various binary mixtures at different temperature, which then generate the data matching up to maximum extent with experimental values are used and represented in table number 3. which I will show later. Here, table 1 represent measured excess molar volume, which I calculate by using their densities. These are the value of excess molar volume. And we can see that the
1 minute left,
graphical
ma'am.
yes, sir.
You have only 1 minute.
Sorry, sir. Okay, sir. We can see that the graphical representation of excess molar volume. And if we discuss about the discussion, we observe that we can see the values of excess molar volume are positive, or the whole mole fraction raised, as methyl laurate is polar and non-associating. So we can say that as we know, methyl laurate is non-associating, and while alcohols are associated liquid in pure state, so there will be disruption of hydrogens molecules. So as increases the temperature, then excess molar volume will be increases. After that, we will discuss about excess isentropic compressibility, which are measured by these equations, and put the values of excess isentropic compressibility in Radley-Fischer equation. These are the values of excess isentropic compressibility, as we can see in table number 2, and the graphical representation of this in figure 2. Discussion. The excess isentropic compressibility for binary mixtures. Here we observe that the values are negative. Why these values are negative? Because there is two factors are dominate on these one factors. If we talk about the factors, first is close packing of molecules, and second is depolymerization of associated molecule species. And here, table 3 are represent that the adjustable parameters, which are calculated by Radley-Fischer equations. If we talk about the conclusion is that I measure density and speed of sound by density sound analyzer. After that, I calculate excess molar volume and excess isentropic compressibility, and then I put these value in Radley-Fischer equation. I found all results that excess molar volume values are positive over all mole fractions, and excess isentropic compressibility are negative over the whole mole fractions. These are the references of my research paper. Thank you.
Any questions from the participants? Okay, since there are no questions, thank you, Sunita, for your presentation. We go to the last presenter for the day, Mahesh. Mahesh, are you ready? Mahesh, are you there?
Ma'am, earlier he was here. I don't know.
Mahesh,
Mahesh is here. Mahesh.
he's there. Mahesh,
Yeah.
you are not replying. Hello, Mahesh.
Hello. Ma'am, I am audible now.
Yes.
I am
you have
here,
to
ma'am.
present now. You get 8 minutes for your presentation. 7
Okay.
minutes ke baad, there will be a bell to tell you that 1 minute is left. And there are 2 minutes for interjection. Okay? Please
Okay,
share
ma'am.
your screen. Put it on full screen mode and start.
Okay, ma'am. My screen is visible, ma'am.
No, not yet.
Your screen is not visible, Mahesh.
Not visible.
Sunita, please be on mute here.
I have shared my already.
Sir, is there any problem?
1 minute. 1 minute. 1 minute. COVID-19.
Can you help him to share his screen?
Can Now visible, ma'am?
नहीं महेश, आपकी स्क्रीन नहीं दिख रही है अभी भी।
तो मैंने
नीचे ना शेयर स्क्रीन का एक ग्रीन कलर का बटन है, आप उसको हिट करें।
शेयर स्क्रीन किया मैंने, इसके बाद OV90 पावर पॉइंट स्क्रीन।
रौनक, प्लीज हेल्प हिम।
Yes, ma'am. Well,
Sir, please click the option of share screen.
शेयर स्क्रीन का ऑप्शन किया मैडम, इसके बाद 5 स्क्रीन इज हियर, शो मी।
Sir, is there any option for PPT?
Yes, OV19 PowerPoint.
Then click on that, sir.
just wait for minutes. Ma'am.
Now visible?
Please wait for a minute.
Okay.
Yes, visible now.
Now visible, ma'am?
Hmm.
Okay. First of all, good evening to everyone. Good evening, ma'am.
Good evening. Please start.
I am Mahesh Rupapra from RK University, PhD scholar. My title is Synthesis of oxidizole, thiazole, chlorochrome hybrid and their antioxidant activities. My presentation is divided in 1 to 7 parts, abstract to conclusion parts. First is abstract. In this study, we set out our to create some new oxidizole, thiazole, chlorochrome hybrid compounds and test them their antioxidant properties. Beta blocker drugs based 6-chlorochrome and 2-carboxylic acid was used as a starting material and was accomplished in number of steps lead to formation of hybrid linked amidic bridge. The antioxidant activity as a ICHE-50 was measured and compound with using ascorbic acid as standard reference standard and found most higher potency when compared with this standard. Among those compound, nitro compound and fluoro compound, fluoro substitute compound shows significant activity. The structure of all these compound proven by well-known technique as IR mass and NMR spectroscopy. This is the introduction of my work. In medicinal chemistry, generally nitrogen, oxygen, and sulfur atoms have been proven to result in improved efficiency against numerous diseases by organic moiety. Due to the presence of toxophoric linkage, 1,3,4-oxadiazole and 1,4,thiazole have so useful pharmaceutical chemistry and material science. And there is much more evidence for the number of publications and patents in the substitution of 1,3,4-oxadiazole and 1,3,4-thiazole are as a prime medicinal and material interest. Oxidative stress has been linked with many diseases and their complication raised in the production free radical and the inhibited antioxidant defense mechanism to deoxify reactive intermediates. I directed the research for the development of new and more potent antioxidant and anti-cancer molecules. aim of my work is according to above result investigation. Bioisoester of 134 oxadiazoles and 134 thiodiazoles and chromen system possess a remarkable biological features may play important role in the development of novel chemical entities. Hence, N and O based research I will continue. We aim to club these three active pharmacophores for possible enhanced potency can be individuals. It was said with started with nebuliol drug. Nebuliol drugs as a antihypertensive drugs. 6-chlorochromen to carboxylic acid as a beta blocker drugs intermediate active fragment to from series of compound of 7A to 7J. Their validity synthesized molecule was assessed by preliminary in vitro antioxidant screening and expressed ICH value. So this is the reaction scheme of my works. Reaction is starting material 6-chlorochromen to carboxylic acid is react with the thiocyanocarbazole in presence of POCl3 to get compound 2. This compound 2 is amidic compound, amidic thiodioxazole compound. And chloroacetyl chloride is react with this compound in presence of acetone at 0 degree to get compound 3. And now new scaffold for this compound, methyl benzoate is react with hydrogen compound and get hydrogenate compound and is react with ethanol in presence of carbon disulfide to cyclize thiooxazole compound. This thiooxazole compound and this amide chloride compound is react with is coupling the both in presence of acetone and carbonate as a base to get 7J compound. This is the R denoted H compound. This 7J compound, we have synthesized the 10 substituted different substituted R is H for HCl3 nitro to have checked the antioxidant activity of these 10 compounds. Now this is the spectroscopic data evaluation of the targeted compound. Next slide is here is the 19F of this fluorinated confirm this fluoro compound. Next is 1H NMR proton NMR of this 7A compound. Here 13.707 is denoted as a NH proton, and 2.78 is this 8 and 12 hydrogen atoms, and this is this benzene ring compound proton of this benzene ring, and this 5 proton is this benzene ring. This is the 1.56 is this chromen ring CH2 denoted by CH2, and this proton is denoted by this 19 number of compound hydrogen atom. Now this is the 13C NMR. 13C NMR is there is a carbonyl group is 166.215 is carbonyl group, and 165.24 is a CF carbon. CF linkage carbon, and 164 to 155 is this benzene ring carbon. This oxadiazole ring carbon 2 and 4 carbon, and diazole carbon 24 and 26. Other than this is the CH2 of this chromen ring. CH2 of this 31 number of carbon, and these 3 carbons is this chromin ring 20, 21, and 19 is determined. It's confirmed this compound 7J compound with hydrogen substituted compound. Now I have checked this there is antioxidant activities of this 10 compound, and here with ascorbic acid as a reference standard. Here we can see the 7C nitro compound is more active, 399.57 is IC15 micrometer, and 7D is 551 is more active in this ascorbic reaction standard, and this is the fluorinated substituted is 574 is also more active in this 10 compound. Out of 10, 4 to 5 compounds is more active than reference standard. Now this is conclusion. Conclusion is the latter phase involves synthesis of chromin oxal thiazole hybrid scaffold using this therapeutic activity and readily available starting material under the mild reaction conditions. Since nitrogen and oxygen are already present in the molecule framework, the concept of this expanded to discover the usefulness of this fluoro group in addition to other heterocyclic for their antioxidant potency. This nitro group adduct 7C compound and 7D compound were shown to have a highest DPPH based antioxidant potency among the UDC, EWG, and halogens, while the 4H and 4CH substituted adducts also had activity remarkable to that ascorbic acid. The scaffold of 7A1 and 7B with the EGES and the simple aryl system were the least effective. Now this is the references of this works totally. This is the acknowledgement. We wish to thank the School of Science, RK University, Gujarat, India for affording the lab facility. We also thankful CDRI Lucknow and COA and Saurashtra University, Rajkot, India, out the spectroscopic analysis and stipulated time. Professor Abdullah Allah Rifi is grateful to research supporting project number King Saudi University, Riyadh, Saudi Arabia for financial assistance. Thank you to all. Thank you.
Thank you. Over to you, Kiran.
Sorry? Yes, ma'am? Hello? Hello?
Yes,
Hello?
ma'am.
Am I audible?
Yes, ma'am. Yes.
Okay, ma'am? Where is ma'am? Ma'am left? Hello? Oh, wait a minute. Where is ma'am? Just wait for. Ma'am has left. Okay, participants. So just formal vote of thanks. So on behalf of Deshbandhu College, I extend my most sincere thanks to the respected chairperson, Professor Sarda Basricha ma'am, and participants from the various different universities and students volunteer for their active participation in today's session. Especially, I would express my gratitude towards an organizing team and to all the volunteers who really have done excellent work and making this event so successful. Thank you. Thank you for joining.
Thank you, ma'am. Thank you,
Thank
all.
you. Thank you so much.
Thank you for organizing of this.
Thank you.
All
All the best. Bye.
Okay, ma'am. Thank you.